Okay, in question 6 part A, we have 3x minus 5 times 2x plus 4. And we're asked to differentiate this from first principles. The first thing you should do is multiply it out and get your f of x is equal to 6x squared plus 2x minus 20. Now at this stage you should look at that and you should tell the derivative of 6x squared is 12x, the derivative of 2x is 2. So you should immediately know your answer is going to be 12x plus 2. And that just, at least if you make any mistakes through the question, you'll know when you get to your answer. So it's really important that you structure it exactly the same way as I've structured this one. We have f of x equals this quadratic. The next thing we need to do is get f of x plus h, which just means that everywhere there's an x, you sub in an x plus h. So I get 6 times x plus h squared plus 2 times x plus h minus 20. You multiply out 2 times this bracket is 2x plus 2h. If you multiply x plus h by x plus h, you'll get x squared plus 2hx plus h squared. If you multiply that by 6, you'll get 6x squared plus 12hx plus 6h squared, and then you've got your other three terms. That's f of x plus h simplified fully. So the next thing you need to do is subtract f of x. F of x is 6x squared plus 2x minus 20. So if you're going to subtract this, you're just changing all the signs. So it becomes a minus 6x squared, a minus 2x, and a plus 20. The reason I've put them there is because they'll cancel with the terms above them. They cancel, so 3 of the terms in my previous line have cancelled. And now so here this was f of x plus h, and now I've subtracted f of x. So it leaves me with f of x plus h minus f of x, which is just 12hx plus 6h squared plus 2h. The next step is you divide everything by h. Everything you had over h. 12hx divided by h is 12x. This divided by h is 6h. And 2h divided by h is 2. And finally, you want the limit as h approaches 0 of everything that you already had. So that means in your mind you should just think, okay, well h is 0. You're subbing in h equals 0. But you don't actually physically write down that you're subbing in h equals 0. 6 times 0 is 0, so you just ignore it. It's gone. And your final answer is 12x plus 2. In B part 1 of this question, we're told that h of x is a half ln 2x plus 3 plus c, where c is a constant. And we're asked to find the derivative of h of x. So you should go to your maths tables to our page on differentiation, and it tells us that the derivative of ln x is equal to 1 over x. And that's the rule that we're going to use in order to differentiate this. First of all, if there's a coefficient in front of the ln, if it's present in the original function, it will also be present in the derivative. So you take down your half. According to the maths tables, ln of algebra, you're just left with 1 over whatever you had after the ln. So ln of 2x plus 3, if I differentiate it, it's just 1 over 2x plus 3. All I'm doing there is just following that rule. However, I need to take into account something else. I've differentiated the ln or the log, but I also have to differentiate the algebra. The derivative of 2x plus 3 is simply 2. So I also have to multiply it by 2. And then c is a constant, and the derivative of any constant is just 0, so I'm ignoring the constant. You should notice now that you have a 2 on the bottom and a 2 on the top that cancel each other out. And this leaves me with my final answer, h of x is equal to 1 over 2x plus 3. And that'll get you the full marks for B part 1. Okay, in part 2, I'm given a graph that represents the function 1 over 2x plus 3. And the shaded region is between the curve and the x-axis. You should remember that to get the area between a curve and the x-axis, we integrate. And we use limits. So the upper end, it's between the curve and the x-axis from a to 0. So if I integrate the curve 1 over 2x plus 3 from a to 0, that will tell me the area between the curve and the x-axis from x equals a to x equals 0. I've been told that that area is equal to ln 3. So I know the integral from a to 0 of this is equal to ln 3. And we're going to use that in order to find the value of the unknown, which is a. So the first thing we need to do is integrate 1 over 2x plus 3. When you integrate 1 over 2x plus 3, obviously you go to your maths tables, the rule on and you go to the page on integration. It tells me that if I have 1 over x, the integral of 1 over x is ln x. So if I have 1 over something, its integral is just ln of whatever was on the bottom, in this case 2x plus 3. However, I cannot forget that if I'm integrating, I then have to divide by the derivative of the algebra. The derivative of 2x plus 3 is 2, so you divide everything by 2. So it's the opposite of what we did in part 1, because in part 1 we multiplied by the derivative of the algebra, which was 2. This time we're dividing by the derivative of the algebra, which is 2. So we divide by 2 because this is integration. And there is no plus c because there are limits. Whenever we're dealing with the limits, we don't add in the plus c or the unknown constant. What I need to do is I sub in the upper limit and then I sub in the lower limit, and I subtract the lower limit from the upper limit. So the first thing I did was I want to sub in a into this. Instead of an x, I simply subbed in a. I got ln 2a plus 3 over 2. And then I put a minus between them, and then I sub in the lower limit, which was 0. So it's ln 2 times 0 plus 3 over 2. I can't simplify the first fraction at all, but the second fraction, 2 times 0, is just 0. So I end up with ln 3 over 2. So at this stage, there's not a whole lot I can do, but I noticed, right, I've got one equation and one unknown, so I can find the value of a. I just need to manipulate it. I addressed at this point, the problem is the fraction. I figured the most difficult thing about this is the fraction. Two of them are over 2. So I decided to multiply everything by 2. I get ln 2a plus 3 minus ln 3 equals 2 times ln 3. And then I noticed that the second term on the left-hand side and the term on the right-hand side are like terms. They're both ln 3's. So I decided to move the ln 3 from the left to the right, and it became a plus. 2 ln 3 plus 1 ln 3 is 3 ln 3. So now I have ln 2a plus 3 equals 3 ln 3. I'm going to just rewrite this up at the top and we're going to continue on. So at this stage I know that ln 2a plus 3 is equal to 3 ln 3. Remember that ln is log to the base e. So we can apply the rules of logs here. The third rule of logs in the middle column on page 21 in your maths tables tells me that if I have 3 ln 3, I can bring the coefficient in front and it becomes a power. 3 ln 3 is the same as ln 3 to the power of 3. So you take the coefficient in front and it becomes a power. Then 3 to the power 3 is 27. Now I've a log to the base e on the left and a log to the base e on the right, so they cancel each other out. And I end up with 2a plus 3 equals 27. Now it's basic algebra and I end up with a is equal to 12. And that's my final answer for part 2.